In this video cast, I will show you how to create a mortgage payment calculator, use data table to apply it to varying interest rate schedule and create amortization schedule. So the very first thing I will do in the mortgage payment calculator, I will define names. So instead of using like F5 minus F6 in the formula, I will use something like price minus down payment, so those formulas make more sense. To do this, I will use defined names option under formulas. And in defined names option, you can define names one by one, or you can create them from selection, which is more productive. So that's exactly what I'm going to do. The first step, I will highlight the two columns, date and item, price, down payment, loan amount, and corresponding values. I will go to defined names, create from selection, and I will apply that I want to create names from left column. As you see, I've checked the left column option, clicked OK, and now what it does, if I click on, let's say, cell D6, it actually defines it in the name box as price, similar to the item definition in the left column. The same with down payment, it's now down payment, loan amount is now loan amount. So I'm going to apply the same steps to these two columns. Go to define name, create from selection, make sure the left column is selected, click OK. Now, if let's say you did something wrong and you want to change it or modify it, you'll go to define names, name manager. In here, you will see all the names that you have defined and the reference cells addresses. And if you need to delete something or edit something, you can do it in here. All right, so I'm going to click out. And now the first step in this mortgage payment calculator, just reminding that for the date we use the function now. The function now doesn't take any arguments because it reads from the computer clock. The item is house, the price is $429,000. The down payment is here, so the loan amount obviously is going to be the difference between the price and the down payment. So equals price minus down payment. And you see how easy it is to read this formula. So instead of saying D6 minus D7, it actually very clearly states price minus down payment. All right, so the next thing I'm going to do is to calculate the monthly payments. And for monthly payments, we're going to use the function PMT. So PMT, the first one is rate. So the rate is obviously 4.125% per year. But since we're calculating monthly payment, we need to divide it by 12 by the number of the months in the year. So it's going to be rate divided by 12, and this is our first argument. The next argument is the number of how many times we're going to pay it, and our term is 15 years, and since again it's monthly payment, during each of these years we're going to make 12 payments, so it's going to be 12 times term times 15 years, and that's our second argument. The third argument is the present value, and the present value of our loan is obviously the loan amount. So I'm just going to enter this, press enter, and we have the monthly payments. But since it is a negative number, the way it is presented, I'm just going to go and add a minus sign in front of the PMT function itself, and so this reverses the sign, and so now it's easier to use it in the other calculations that we are going to do. So the number is still the same, it just we got rid of this negative sign. The next step is to calculate the total interest, and the total interest is obviously the total amount we're going to pay minus loan amount. So it's going to be monthly payment, right? So it's going to be monthly payments times term times 12, since we're talking about 12 months in each year. And now we're going to subtract the loan amount, and this is going to be our interest. And of course, the total cost, you can calculate it in a variety of ways, but the easiest way would be the price plus the total interest. That's how much we're going to pay on this mortgage. The next step is we're going to create the varying interest rate schedule. We already have a preset table for this with all the rates starting from 3% and up to 4.25. And so, as you please note that the row 13 is empty. We're going to enter the current data from the mortgage payment calculator, the one that corresponds to the rate of 4.125. So for monthly payments, it's obviously going to be cell F6. So it's going to be equal F6. For total interest, it's going to be cell F7, this one, right? Okay, so equal F7. And for total cost is going to be cell F8 equals F8. The reason I'm not just clicking here and not using the predefined names, because the predefined name is very similar in its essence to the absolute cell value. And so if I use those, they will always point to these specific cells and will resist any redirections or any, as you remember, if you copy just a regular cell address in a different column or in different row, in the formula, the Excel will update those. If you use absolute cell address, absolute cell value, it will not update it. It will always point to the same cell address. So this is the reason I'm using the relative cell address. And now what we need to do is to apply data, use data table, and it will apply the information that we have currently with the rate of 4.125 to the variety of the rates. To do this, I will go to data, to what if analysis. Okay, so in what if analysis is in under the forecast, and once we're in there, we're going to use the data table. But before we do this, we actually need to select the area where we're going to apply this data table to. So I'm going to select everything, starting from C13 and all the down to F23. And I'm going to click on what if analysis data table, and now it wants me to use either row input cell or column input cell, and obviously since our rate is changing by the column, so that's what I'm going to use. And our input cell for the rate is that we have currently is 4.125, so it's F4. I'm going to click, oops, sorry, the column F4. So I'm going to click OK, and it creates the data table corresponding to the rate that is in column C. So this gives you a better understanding of how interest rate changes depending on the annual rate. Now we're moving to amortization schedule. And the very first entry in I5 is going to be the beginning balance. And beginning balance is obviously is in cell D8. It's our loan amount, correct? So that's all I'm going to do, stack D8. That's my beginning balance. Now with the ending balance, it's going to be a bit more complicated. We will have to do some calculations here. Because the beginning balance, ending balance depends on several factors, I'm actually going to use an if statement. And my very first logical test is going to be that I will check if my H5, which is the year which I'm calculating the ending balance for, is less or equal to F5, and F5 obviously is the term. So what I'm checking if I'm still under or equal to 15 years, okay? So it's going to be H5 less or equal to F5. And now please note that the H5 address is going to update depending on which year you're in, correct? So for year, currently it's year 1, then in next row is going to be year 2, but F5 should always stay the same. So it always should point to the term. So I'm going to press F4 to make the cell address absolute, okay? And I'm going to move to my next argument, what should it show if the value is true? So for this, I'm going to use the function PV, which returns the present value of the investment. And please note that it's a function within another function, PV function within if function. It is called embedded function. So the PV function going to take several arguments, and the first one is the rate, and the rate is located in cell F4, correct? F4, but again it is an annual rate, and okay, let me just double check. Is it F4? It is F4. Okay, it's an annual rate, so we need to divide it by 12 months, right? Okay, and again, because this address should not be changing, whether we're changing a column or whether we're changing a row, I will make it an absolute value, an absolute cell address. So I'm going to press F4 and enter those dollar signs in front of the column and in front of the row. So this is the first argument for PV function. The next argument is going to be we will need to calculate the number of total periods, and so this is going to be obviously F5 minus H5, correct? And times 12 months. So let me put it in parentheses, F5, and I'm going to make it an absolute value for obvious reasons, minus H5, close parentheses, times 12 months, okay? And The next argument is going to be the payment, which is the value that we have in F6. So let me just put F6 in here, our PMT. And now I just wanted to remind you that first of all, it has to be an absolute cell address. And second, remember when we use the calculations, we actually changed the sign for the monthly payment, so it still shows as a positive number. So we will need to reverse this back because this is a negative number in reality, so I'm just going to add this minus in front of this argument, which will reverse it all back to where it was. All right, so these are the arguments that PV function takes. Now I'm going to close the parentheses to show that I'm done with the arguments for PV function, and also I'm done with the second argument for if function, which will show us the number if the value is true. So I'm going to put comma to move to the next argument. What should it display if the value is false? Obviously it's going to be a 0, and I'm done with my if function. Yes, I forgot to put the closing parenthesis. All right, so now we have the ending balance, and we can move to how much we paid on principal. And obviously it's just going to be I5 minus J5. So I5, this is our beginning balance, and J5, the ending balance. So that's how much we paid on principal. And now we are going to also display how much we paid on the interest. And again, in here, you can do it in a variety of ways. I'll just show you how to use if function and what arguments it's going to take. So the first one, the logical one, the logical test is I'm going to compare to see if my I5 is greater than 0. Okay. I5 should be greater than 0, because if it's already 0, then obviously we should just stop calculations. And the second argument, what should I display if the value is true, is going to be, okay, so F6, right, the monthly payments, F6 times 12, again, because it is the, oops, sorry guys, F6 times 12, and I just showing in the formula bar, okay, because this is the how many payments per year is going to happen, 12 payments, minus K5, which is how much we paid on the principal, right? Okay, the only thing we need to add is to change F6 into the absolute cell address. Okay. And so this, what it should display if the value is true. If value is false, meaning that if the number in beginning balance is equal 0, then it should just display 0. All right, so now we have all the numbers here intact, and the only number I'm going to add before I just do the autofill is I will put the beginning balance for year 2, okay, because obviously it's going to be different from how I obtained the beginning balance for year 1. For year 1, I just copied the number from mortgage payment calculator. Okay, so for year 2, the beginning balance is going to be equal to J5. The value in J5, okay? And now I can start copying the functions that I have created. So autofill for ending balance, paid on principal, interest paid. And now I can just go ahead, highlight the whole row, and just autofill the rest of it. So now you will see that we reached year 15 and the ending balance did reach 0. Okay. All right, so basically that's it. We have created amortization schedule. You can calculate subtotals for each of the, like for how much you paid on principal, how much interest you paid. You can also transpose the down payment to total cost, but we have these numbers already in the mortgage payment calculator, so if you're interested, you can do it on your own.